Welcome to our Winning Teams Pocket Lesson series. You should use this series together with the Learner Book and the Questions for Teams books from Winning Teams. This series provides important support for you and your team as you prepare to play the Winning Teams game. It will help you to understand the maths and give you examples for practice. Work through it at your own pace. You can stop and replay any part that you need to hear again. In this series of lessons, we work with functions and their graphs. In this lesson, we look at the definition of a function. What is a function? This topic is also covered in the Winning Teams Learner Book. This lesson helps you to prepare for using the question cards in the Winning Teams game. We start with functions and their inverses. Then we look at the grade 12 work on exponential and logarithmic functions. We return to the grade 11 functions and graphs, which are also examined in your final examinations for grade 12. You have worked with the formulas and graphs of functions in previous grades, but you may not have defined a function before. First, let's look at a simple relationship between a set of x values and a set of y values. If you are given a set of x values, you can work out the set of y values, or answers, that come from using a given rule on each x value. So, there is a relationship between the x values and the y values that is described by the rule. In earlier grades, you showed this with a flow diagram. The x values are the input values, and the y values are the output values. Look at this flow diagram. Use the rule y equals 2x minus 1 on these values. So, for every x value, we times it by 2 and subtract 1 to find the y value. For x equals minus 1, y equals 2 times minus 1, which is minus 3. For x equals 0, we get y equal to 2 times 0 minus 1, which is minus 1. For x equal to 1, we get an answer of 1. For x equal to 2, we get an answer of 3. And for x equal to 3, we get an answer of 5. Remember that the input values or x values are the elements of the domain of the set, and the output values or y values are the elements of the range of this set. We can plot these pairs of x and y values on a Cartesian plane. Here are 3 of them: 0, minus 1, 1, 1, and 2, 3. Let's extend the domain of this set to any x that is an element of the real numbers. Using the rule, for each x value, we can multiply by 2 and subtract 1 to find the y value. These points will all fall on a straight line that joins the points we have already found. If a rule or a formula produces only one y value for each x value, then we have a function. An easy way to check this is to look at the graph and use the vertical line test. Place a vertical line anywhere on the graph. Use a ruler to do this. Do you see that it cuts the graph at only one point? At this point, we have one x value and its y value. If I keep moving the vertical line to different points, it still only cuts the graph once. This shows us that for every x value on the graph, there is only one y value, and so it is a function. We can write the rule for the function like this: f of x equals 2x minus 1. This means the function that acts on the x values uses the rule 2x minus 1. F of x means the value of f at x, or the y value of the graph. So, f of x equals 2x minus 1 is the same as y equals 2x minus 1. Let's check some other graphs. You've worked with quadratic functions such as y equals x squared minus 4 before. The graph of this is a parabola. By looking at the graph, can you say if this is a function or not? The vertical line does not cut the parabola more than once, no matter where you place it. So, for every x value on the graph, We still have only one y value, so this is also a function. Now look at the y values. For example, look at y equal to 0. Do you see that x can be 2 or minus 2? This shows that there are two x values for a y value. But this does not show us anything about whether the graph represents a function. Look at this graph. If we put a vertical line anywhere on it, except at the turning point, it cuts through the graph twice. So there are two y values for an x value. So this is not a function. The formula for this graph is y equals plus or minus the square root of x plus 4 for x an element of the real numbers. We can check a point on the graph algebraically. When x is 0, y equals plus or minus the square root of 0 plus 4. That's the square root of 4, which is positive 2 or negative 2. So y is 2 or y is negative 2. So there are two y values for x equal to 0. So this is not a function. So let's look at the important things about a function. If in a relationship between x values and y values, every x value or input value has only one y value or output value, then the relationship is a function. The function can be represented with a formula, for example, f of x equals 2x minus 1, and with a graph. One way to test whether a graph represents a function is to use the vertical line test. State whether the following graphs represent functions or not. Give a reason for your answer. The first two graphs are functions because there is only one y value for each x value. You can check this with the vertical line test. The third graph is not a function. For example, the graph cuts the y-axis at 3 and minus 3. So for x equal to 0, there are two y values. In this lesson, we have looked at what makes something a function. Use your learner book or a textbook for more practice on this topic. In the next lesson, we look at the inverse of a function.